Hi Mo girl, what's the latest on Gamora? Hi Mo girl, apparently Tuggy is hiding that Longa is Malusi's son, and Malusi's wife is furious that Malusi is spending most of his time with Longa, and he will eventually figure out that Longa is his son. I really think no matter how jealous Gladius might be, Malusi still needs to know the truth. Hiding that Longa is Malusi's son will jeopardize her relationship with Malusi even more. Anyway, Science Explained is about to start. We need to go.
Hi everyone, I'd just like to welcome you to Science Explained with Mr. K, and this is another episode, guys, where we are going to just wrap up everything that we've learned so far regarding the organic chemistry. Right, just to quickly summarize everything, guys, we have alkanes, alkenes, and alkynes. Now the force that is associated with these families is called the weak van der Waals forces. Now, because it's a weak van der Waals forces, guys, then it means in this type of families, we are going to get low melting point, we are going to get low boiling point. In other words, what do I mean? We are going to get a negative temperature of a melting point and a negative temperature of a boiling point. Yes, that is possible. Your alkanes, alkenes, and alkynes, they boil, guys, at a negative temperature. So meaning these type of families in nature, they can only exist as what? As gases. Right, and then when we talk about your haloalkane is going to be a bit different from the alkane, alkene, and alkynes. Why? Because I am adding a halogen to an already existing alkane, which changes the entire structure from being non-polar to being a polar molecule. So in this case, the type of force that will exist here is going to be a dipole-dipole, which is also said to be what? A strong van der Waals force. Right, for aldehydes and ketones as well as esters, we also have this type of force, which is a strong van der Waals force, which is also what? Which is also a dipole-dipole force, guys. Now, you would realize that your haloalkanes, your aldehydes, your ketones, and your esters share this type of a force. That's simply because of the structure, guys. I want you to understand that because we are introducing something to an already existing structure, then it makes it negative and positive. That's why we say the type of force there is going to be what? A dipole. Now for alcohols, on the other hand, we are going to talk about your hydrogen bonds. Okay, the hydrogen bonds, guys, they are stronger than the weak van der Waals force as well as the dipole-dipole. Now because of the OH, guys, your alcohols are going to have the hydrogen bonds. Now the last family that we look at is the carboxylic acid. The carboxylic acid, if you can look at this structure, it has a double bond to oxygen and it also has a single bond to OH. Now, for that, we have two types of forces. That means we are going to have a dipole-dipole and we are also going to have a hydrogen bond. So, meaning your carboxylic acids, guys, they are the strongest in terms of strength, in terms of the intermolecular force strength, they are the strongest. Okay? Now, just to summarize everything, I just mentioned that for alkane, alkene, alkynes, we have the weak van der Waals forces, which are also called your London forces. Now they are associated with low melting point, low boiling point, okay? And then when you look at the energy required, guys, to break the force that is holding the molecules together, the energy required to break that is going to be less, simply because these are already weak in terms of forces, okay? And when you look at your vapor pressure is going to be at the stage high, because what is vapor pressure? Vapor pressure talks to the tendency of a substance changing into a gas phase. So in this case, because your alkanes, alkenes, and alkynes have weak van der Waals forces, they can easily turn into a gas.